Let's start now with our new lesson in chapter 12, lesson 3, which is an inscribed angles. In this lesson, we are going to find the measure of an inscribed angle and the measure of an angle formed by a tangent and a chord. Now, but before going to talk about how to find the inscribed angle, let's see now what is the inscribed angle, what is the central angle, what is the difference between them. Now, all of us know that if you need to draw any angle, you need two sides with this point here, which we call it a vertex. So any one, it must need two sides with this point, which is a purple here, which is a vertex. Now, if we have a circle, and this circle here, it contains an angles, and each circle has a center. This is a center of a circle. Now, if we have this angle here, but this angle now is on a center of a circle, and there two sides now this angle here, its vertex is in the center, and its two sides are ending on the end points of the circle, or are on the circle. This type of angle, that is its center, or its vertex on the center of the angle, we called it central angle. So its vertex here is on the center on the angle. Its vertex in the center of the angle, so we called it central angle. And if there's another angle, it's like this, but this one here, its vertex, it's not on the center, it is on the circle, starting from one point of the circle, and their sides it has the vertex on a center on a circle, and their endpoints on a circle too, which this type of angle we called it inscribed angle. So this will be now an inscribed angle. So the difference between them, both of them have 2 points on a circle, but the central angle, its vertex is on the center of the circle, and the inscribed angle, its vertex on the circumference of the circle. Now, this is the difference between them. Now, what's the relation between them? Look at the central angle here. Here we have a central angle, and here we have this arc. Now, the central angle and the arc, what did you mean about the relation between them? If you want to find the measure of the arc, did you remember what did we say?
How did you measure the angle?
The measure
that it is of the tangents
of the arc equal the measure
of the angle
of the central angle. So this is what did we say before. Now which arc? Now, since here we have these 2 points, wait, please. Since we have now these 2 points, this one and this one, they are these 2 points are connecting between, or are a vertex, are the sides of an angle, and it's make an arc. This arc we called it intercepted arc. So this arc is intercepted arc. So the name of this arc here is intercepted arc. And the measure of this intercepted arc is the measure of the central angle. And today now we will learn a theorem that tells us that the measure of the inscribed angle is half the measure of the intercepted arc. So the measure of the arc, it could be the same as the measure of the central angle, and it could be double the measure of the inscribed angle. So the measure here of the arc is half the measure of the inscribed angle. So the intercepted arc, it can be found by the measure of the central angle, they are equal, and by the inscribed angle, whereas the inscribed angle is half the measure of the arc. Right. Since now the measure of the arc is equal the central angle, and the measure of the arc is equal the inscribed angle, what can we conclude?
We can say that the measure of the inscribed angle will equal the measure of the arc.
That's here the central angle.
It's half the inscribed angle.
That's double the inscribed angle.
Okay.
So that's mean if you have the intercepted arc as an example, wait a minute, please. If it is like 80 degree, so the central angle, it will be 80, and the inscribed, it will be 40. Is it clear? What's the difference between them and what is the relation between them? The central is double the inscribed. Half of the center is inscribed. The central angle is to have the same measure as the intercepted arc. Is it clear?
Yes. Yeah.
Teacher, can you repeat this last one? The central angle equal to inscribed angle?
From here, we say that the measure of the arc is measure of the central angle, and the measure of the arc is 2 or double, يعني measure of the inscribed angle. So we can conclude that the measure of the central is double the measure of the inscribed.
Okay, teacher, thank you.
So here, as we said, that this is a central angle, this is an inscribed angle, this is the central, the intercepted arc. Now let's see what is the definition of the central angle. It is an angle subtended by an arc of the circle from the center of the circle. And the inscribed angle, it's an angle subtended by an arc on the circle from any point on the circumference of the circle. Now, alpha is, this is alpha, which is the central angle, is double theta, double the inscribed angle, or theta is half alpha. Or I mean, you can say that's like an central angle is double the inscribed, or the inscribed is half of the central angle. That's what we, so this is the definition of the inscribed angle, the intercepted arc, and the central angle. Now let's come back now to our lesson to see what is our theorem here. Our theorem that the measure of an inscribed angle is half the measure of its intercepted arc. And I mean, if I am talking about this angle, I will not look about the measure of this arc or the measure of this arc. No, you will look at the measure of its intercepted arc. Where's the intercepted arc? Any arcs, when you want to draw it, you need 2 points. And it's a curve. These 2 points are from the points of the angle. So this will be now the intercepted arc, which is an arc that is opposite to the angle. The relation between them is the measure of the angle ABC, or the angle B, is half the measure of the arc AC. So, like if you have here this circle, and now look at the semicircle here. What is the measure of the semicircle?
180.
Since it's 180, so the central angle will be 180, because the central angle has the same measure as the intercepted arc. And the angle that is on the circumference of a circle and connecting between the end points of this arc have the same, will be half the measure of the arc. So that means this angle here is 90. It is where I mean like if you have this circle here, for this one as an example, for this inscribed angle, where's the arc of it? It will be this arc. It starts from this point, ending at this point. Now, if I tell you that this is an semicircle, so its measure is 180. Since it's 180, so the measure of the inscribed angle will be half the measure of the arc, which is 90. Let's have now more examples here. Here now in problem number 1, we have an A, this is an arc A and angle B, and you want now to find the values of A and B. Now, for this angle here, which is 60, let's wait a minute. Now, for this angle here, which is angle 60, let's see where are its sides. It is this one and this one. This is the sides of the angle. So since this is the sides of the angle, so that's mean we have this endpoint and this is the other endpoint. It is here. So their endpoints are P and T. So where it's intercepted arc, it will be PT.
Teacher,
Yes.
how did you know?
Okay, I will repeat it here. Now, angle 60. For this angle here, 60 degree, we said that each angle has two sides. This is the first side, and this is the second side. Now, look at the sides here. Where are the two endpoints? They are P and T. Is it right, Maya?
Yeah.
So since there are P and T, so this will be the intercepted arc. The arc that is connected between the two sides of a circle will be an intercepted arc.
Oh.
I mean, like if you have this circle here, and you have this one, it is on the circumference. So since we have this angle here, the two sides for this angle are this point, are this and this point. So if you have here A, B, and C, so which arc is an intercepted arc, Maya? Is it A or B or C? Is it arc B
A.
or arc C or arc A?
A.
A, bravo. Because the two sides of this angle are connected between the 2 points of the arc. So it will be arc A.
Teacher, I meant that. Can you see the points P and R?
Yeah, but I didn't talk about them. I only talk about 60 now.
Okay.
So here we have this angle. So this is the arc. Now let's come back to our theorem. Our theorem says that the measure of the inscribed angle Q is half, it's not Q, PQT. The measure of the angle PQT is half the measure of the arc, which is PT. So the angle 60 here is half the measure of the arc. So since we have the angle here is 60, half A, so A, it will be 120 degree. So this is here 120 degree. Now I need to find B. To find B here, where's angle B? This is angle B. And this angle B, where's the end points of it? It will be this one, S, and P. Then, so it will be S and P. So for this angle PRS, where is its intercepted arc? It is PTS.
PT.
It will be this angle, this one. From P to S, which arc? It is PTS. طيب, what is the measure of the angle of the arc PTS?
It's
120 plus
30
plus 30,
plus 30.
which is 150. Half of 150 will be 75. So the measure of angle B is 75 degrees. Look at it now. Do you have any question?
No.
Teacher, why is it 75? Isn't it 120 plus 30?
This one here. I want now to find the measure. Here we have P, here we have T, and here we have S. PT is 120 and TS is 30. I want to find PTS. So what you have to do? You have to add 120 plus 30.
Oh, okay. Then you find the 75.
Yes, then half of 150 is 75, which is the measure of the angle B.
Okay, thank you, teacher.
You're welcome. Now I will stop here now.